Hello my dear students. Today we'll have some examples about Faraday's laws. Okay, the first example, calculate the mass of each of the gold and chlorine produced from the passing of a quantity of electricity equals 10,000 coulombs in an aqueous solution of gold 3 chloride, knowing that the reactions at the two electrodes are 2 chloride ions aqueous gives chlorine gas plus 2 electrons, and gold positive 3 reduced by 3 electrons to give gold 0 solid. So this is the quantity of electricity. The actual quantity of electricity equals 10,000 coulombs. This is the first thing. And here we're given the atomic masses of gold and the atomic mass of chlorine. So here the equivalent mass of gold equals its atomic mass divided by its charge. Here we see the charge of the gold positive 3. So the equivalent mass of gold equals the atomic mass of gold, which is 196.98 divided by 3, which is the charge of the gold here, to acquire the equivalent mass of gold. So we can calculate it with each other. 196.98 over 3, it equals 65.66 grams of gold. This is the equivalent mass of gold. Equivalent mass of gold. Let's have in a frame. This is the first thing. Here we want also to calculate the quantity of chlorine which is deposited or liberated at one of the electrodes by some quantity of electricity. So we have to calculate the equivalent mass of chlorine. Here we find chlorine positive -1 charge. So the atomic mass of chlorine, equals its equivalent mass. As the charge is 1, so the atomic mass of chlorine over 1 equals the equivalent mass of chlorine. So the equivalent mass of chlorine equals the atomic mass. The equivalent mass of chlorine equals 35.5 grams. So we know that 1 Faraday here, according to chlorine, will precipitate 1 chloride. 1 chloride mole, it equals 35.5 grams. 1 Faraday, it equals 96,500 coulomb. So if we use 96,500 coulomb, it will separate, or it will liberate 35.5 grams of chlorine. So how many will be separated if we use 10,000 coulombs? So we have cross multiplication to find the mass of chlorine at one of the electrodes. So here X, which is the mass of chlorine, equals 35.5 times 10,000 divided by 96,500 coulombs. So let us have it by calculator. So X equals fraction 35.5 times 10,000 over 96,500. It equals 3.67 or 3.68, 3.68 grams approximately. So here we want to calculate the amount of gold which is liberated at one of the electrodes by using 10,000 coulomb as quantity of electricity. We know that the equivalent mass of gold that we calculate from this relation 196.98 over 3, which is the atomic mass of gold over its charge, which is 3, we have here 65.66. So the equivalent mass of gold, the equivalent mass of gold requires 1 Faraday, or the equivalent mass of gold, which is 65.66 grams, will require the equivalent in coulomb of 1 Faraday. We know all that 1 Faraday required is a quantity of electricity required to deposit or liberate the gram equivalent of any substance on any electrode. So this is the equivalent mass of gold. Equivalent mass of gold here liberated by 1 Faraday, or 96,500 coulomb. So how many grams of gold will be liberated if we use 10,000 coulombs? So how many grams of gold will be liberated if we use 10,000 coulombs? So we can calculate it with each other here. So X here equals 65.66 times 10,000 over 96,500. So here let it do it with each other. 65.66, this is the equivalent mass of gold, times 10,000, the amount of electricity that we use, divided by the equivalent of Faraday, 60,500 coulomb. So it equals 6.8 grams of gold. This is the amount of gold that is precipitated, and this is the amount of chlorine that is liberated as their electrode. In each case, we have to calculate the equivalent mass of chlorine, calculate the equivalent mass of gold. In case of gold, the equivalent mass requires 1 Faraday to be liberated, which equals 96,000. And how much grams will be precipitated of gold if we use 10,000 grams? Cross multiplication, we will have the solution. Here, equivalent mass of chlorine, 35.5, as we have said that the chlorine has only one charge, so the atomic mass equals the equivalent mass. So equivalent mass requires 1 Faraday, which equals 96,500. So how much of this, how much grams of chlorine will be precipitated when we use 10,000 coulombs? Cross multiplication, and the result is 3.68 grams. Let's have another example. Here, another example, calculate the quantity of electricity required to liberate 5.6 grams of iron from iron 3 chloride. 3 here means the charge on the iron is positive 3. It is a ferric chloride solution. Knowing that the reaction at the cathode is iron positive 3 aqueous plus 3 electrons reduced to iron 0. So what is the idea here? The idea here is that we want to calculate the equivalent mass and make a relation between the quantity of electricity and the equivalent mass, and by this we can know how much quantity of electricity will require to liberate this amount of iron. So the iron here as we have given, its atomic mass of iron, equals 55 0.86 grams. So the equivalent mass of iron equals its atomic mass divided by the number of charges of iron. So atomic mass is 55.86, sorry, divided by 3, which is the charge of the ion, equals, let's have calculated together, fraction 55.86 over 3. It gives 8.62, 18.62 grams. So this is the equivalent mass of iron, So what is the benefit of calculating the equivalent mass of iron? This is the quantity that we use 1 Faraday to precipitate it. So we have here the iron and the quantity of electricity. Iron here, the equivalent mass of iron related to 1 Faraday. Equivalent mass of iron here is 18.6 grams. 1 Faraday equals 96,500 coulomb. Why I write it in coulomb? Because he wanted, the question here want the quantity of electricity in coulomb. If he wanted in Faraday, I would have replaced coulomb with Faraday. So 1 Faraday equals 96,500 coulomb, and it is required to precipitate the equivalent mass of iron, which is 18.62. Okay, so we have to cross multiplication if we want to know that how much of electricity in coulomb will be required to precipitate this amount of iron, 5.6. So by cross multiplication, x equals 5.6 times 96,500 over 18.62. Let's have it with each other. Fraction 5.6 times 96,500 divided by 18.62. Yes, it equals 29,022.55 coulomb. Okay, this is the second example. Calculate the time here required to deposit 2.16 grams of silver by passing an electric current with a strength 32 ampere in an aqueous solution of silver nitrate, knowing that the reaction at the cathode, silver positive 1 with electron gives silver 0 solid. So we have here the atomic mass of silver. The atomic mass of silver here is 108, and its charge is 1 charge. So the equivalent mass of silver, here, equivalent mass of silver equals its atomic mass over the number of charge, the oxidation state or the number of charge. Okay, so atomic mass of silver, it is given here 108 over 1, which is the number of charges, it gives 108. So the atomic mass equals the equivalent mass. So the equivalent mass of silver equals 108 grams. So what is the benefit of that? This amount of silver requires 1 Faraday. So the amount of silver here, the equivalent mass of silver here, will require, which is 108 grams, will require 1 Faraday, which equals 96,500 coulomb. So now we have calculated we make a relation between the equivalent mass of gold, of silver, and the required quantity of electricity. So here we have 2.16 grams. How much of electricity we require to precipitate this grams of silver? 2.16. So 2.16 grams of silver requires how much of electricity in coulomb? So X here equals 2.16 times 96,500 coulomb over 108. This is a cross multiplication, normal cross multiplication. So we have to calculate it together as before. So fraction 2.16 times 96,500 over 108 equals 1,930 coulomb. 1,930 coulomb. This is the quantity of electricity which is required to deposit 2.16 grams. So this is the whole quantity of electricity. Yes, the whole quantity of electricity here, 1,930 coulomb. This is required to deposit this amount. So what is the relation between the quantity of electricity and the electric current intensity? The electric current intensity multiplied by time equals the quantity of electricity. So the current intensity here, or the time here, sorry, equals the quantity of electricity over the current intensity. So the time required from this example equals the quantity of electricity in coulomb over the current intensity. So the quantity of electricity equals 1,930 coulomb over the current intensity here, 32. It is given in the example here. So let's have it. Fraction 1,930 over 32, it equals 60 seconds, 60.3 seconds. So here example number 4, on passing an electric current with a strength 7 ampere. So the current intensity is 7 ampere. In an aqueous solution of nitrate for 4 minutes. The time 4 minutes. The cathode mass increased by 1.88. So the cation here, or the metal precipitate, or the quantity of the precipitated cations on the cathode equals 1.88 grams. This is the precipitated or the liberated mass of the substance. Okay, calculate the equivalent mass of the substance. So he wants the equivalent mass to be calculated. This is what we want to calculate of the cations which are present in the solution. Okay, now first we have the current intensity and the time. From the current intensity and the time, you can calculate the quantity of electricity. So the quantity of electricity in coulomb equals the current intensity in ampere multiplied by the time in seconds. So the quantity of electricity in coulomb equals 7 ampere times 4 minutes multiplied by 60 to render it in seconds. So the quantity of electricity equals, let's calculate it, 7 times 4 times 60, it equals 1680 coulomb. 1680 coulomb. This is the quantity of electricity used to precipitate this amount. So the quantity of electricity, 1680 coulomb, used to precipitate 1.88 of this element in grams. So how much of this element will be precipitated when we use 96,500 coulomb, which is required to precipitate the equivalent mass? So the equivalent mass here can be calculated from this equation: cross multiplication 96,500 times 1.88, so over 1680, and let us calculate it with each other. So fraction 96,500 times 1.88 over 1680, it equals 107.98. 107.98 grams. This is the equivalent mass of the element, and if you remember that it is the equivalent mass of silver. The silver is 107.88 or 0.98, okay, or 108. So it is silver. It is silver ions. This is the equivalent mass, and the notion here, or the idea of this solution, is we calculate first the amount of electricity which is required to precipitate this amount, the actual amount, and make relation between the grams, the quantity of the liberated substance, and the quantity of electricity. So we find that 1680 coulomb quantity of electricity required to precipitate 1.88. So how much will be precipitated if we use 1 Faraday, which equals 96,500, to precipitate the equivalent mass of the substance? Cross multiplication, we find this substance is equivalent mass equals 107.98. Example number 5. Calculate the number of moles of aluminum produced from the electrolysis of molten aluminum oxide Al2O3 on passing an electric current of a strength 9.65 ampere. So we have to write the current intensity, or the current strength, 9.56. So the current strength I, or intensity, equals 9.65 ampere. This is the first thing. For 5 minutes, so time given is 5 minutes. Okay. Knowing that the reaction at the cathode is aluminum positive 3 reduced with 3 electrons gives aluminum 0. And it is given here the atomic mass of aluminum is 27. So from this current intensity and time, we can calculate the quantity of electricity required to deposit this amount. The quantity of mass which is required, which is deposited by this amount, is required. So we know that the equivalent mass of aluminum requires 1 Faraday to be precipitated. So 1 Faraday equals 96,500 coulomb requires to precipitate the equivalent mass of aluminum. But the equivalent mass of aluminum equals the atomic mass over the charge. So the equivalent mass of aluminum equals the atomic mass, which is 27, over the charge, which is 3, equals all 9. So 9 grams of aluminum requires 96,500 coulomb. So how much this quantity of electricity will precipitate in grams? So we have to calculate first how much of quantity of this electricity. The quantity of electricity in this case, Q equals the current intensity multiplied by the time. So the quantity of electricity equals 9.65, the current intensity multiplied by 5 multiplied by 60 to render it in seconds. This is in minutes. So let's calculate it with each other. Current intensity 9.65 times 5 minutes times 60 to render it in seconds equals 2895 coulomb. This is the quantity of electricity. So 96,500 will precipitate 9 grams. So 2,895 coulombs. How much of grams of aluminum will it precipitate? Let's have it together. Now the precipitated amount in grams by cross multiplication, 9 multiplied by 2,895 over 96,500 coulombs. It gives, let's calculate it together, fraction 9 times 2,895 over 96,500 equals it equals 0.27 grams. So this is the quantity of electricity which is deposited at this by using this quantity of electricity, the actual quantity of electricity. How we can calculate it? We calculated that the equivalent mass of aluminum, which is 9 grams, requires 96,500 coulomb. So how much will be precipitated if we use this quantity of electricity, which composed of 9.65 ampere in 5 minutes. So we calculate the quantity of electricity and make cross multiplication to find this is 0.27 grams of aluminum. So how much this grams will equal in moles? Is there any relation between these grams of aluminum and the number of moles of aluminum? Yes. Now, moles of aluminum or number of moles of aluminum equals the actual mass, which is here 0.27, over the atomic mass, which is 27. It equals 0.01 mole. Let's have it in calculation if you do not believe me. Okay, 0.27, fraction 0.27 over 27 equals 0.01 mole. And this is the answer of this question. Now, another example. What is the quantity of electricity required to deposit 54 grams of silver from silver nitrate solution? So, we're given here the atomic mass of silver. So, what is the relation between Faraday and the atomic mass of silver? So, atomic mass of silver, we want to calculate first the equivalent mass of silver. Equivalent mass of silver equals its atomic mass 108 over the number of charge of silver. Silver is monocharged or monovalent. Its charge is positive 1. So the atomic mass over the charge equals 108 grams. This is the equivalent mass. Okay, so the equivalent mass is 108. grams. It is related to 1 Faraday. So 54 grams related to how many Faradays? Cross multiplication equals 1 multiplied by 54 over 108. It gives 0.5 Faraday. Now the correct one is 0.5. Another example, a quantity of electricity equals 1 Faraday was passed in 3 electrolytes connected in series containing silver, nickel positive 2 and chromium positive 3. So 108 grams of silver were deposited. So what are the masses of deposited nickel and chromium? Now we see the used quantity of electricity is 1 Faraday, as it also it is assured that it is 1 Faraday as it liberates from silver 108, which is the equivalent mass of silver. So it will liberate the equivalent mass of nickel. Nickel here approximately 60 and has two charges. So the equivalent mass of nickel equals the atomic mass of nickel over 2 divided by 2. So it is nearly 30 or less. So here nickel mass around 30 only here. So it is the correct answer. Let's have assurance of this. Calculate the mass of chromium. Chromium here, the atomic mass is 52 and the equivalent mass of chromium is 52 over 3, which is the charge of the chromium. So 1 Faraday will also precipitate the equivalent mass of chromium, which is 52 over 3. So 52 fraction 52 over 3 equals 17.33. Yes, it is A is the correct choice. Another example. So what is the time required for the electrolysis of 36 grams of acidified water using an electric current with intensity 3 ampere? Okay, we have here the current intensity 3 ampere. He wants the time. The time is wanted to be calculated. So 36 grams we have here from water. We know that water, its atomic mass, its molar mass equals 18 grams. Hydrogen, 2 hydrogen multiplied by 1 plus 16 atomic mass of oxygen, it equals 18. So this is 36. How many moles of water in this case? The number of moles of water equals the actual mass over the molar mass. 36 grams over 18, it equals 2 moles. Okay, 2 moles here, 2 molecules of water related to 2 hydrogen gas moles and 1 oxygen gas. So we can take this or that to know how much electrons will be used to oxidize this or reduce this, or if it is in galvanic cell, or oxidize oxygen in anode, leaving electrons, and reduces hydrogen at the cathode and acquire electron. Okay, no problem. How the electron we use, how we use electrons, but it is the problem of how much moles we use. Okay, we want to know how much moles of electrons. So we use 4 hydrogen atoms. 4 hydrogen atoms reduced or oxidized, no problem. It gives 4 hydrogen ions plus 4 electrons. So here we have 4 moles of electrons, 4 moles of electrons, and they are related to 4 moles of Faraday's unit. So this 36 grams, which is 2 moles, required 4 Faradays to be precipitated. So what is the problem here? The problem here, he gives us the ampere and want us to calculate the time. So we have to know the quantity of electricity first. Okay, this 4 hydrogen require 4 amount of Faraday. 1 Faraday equals 96,500. So how much of Faradays in column will be required? 4 Faradays equals how much? So cross multiplication, it equals in column 4 times 96,500 to precipitate this amount of water, acidified water. So let's calculate it. 4 times 96,500 equals, it is 386,000 coulomb. So this is the quantity of electricity. Is there any relation between the quantity of electricity and the current intensity? Yes, if we multiply the current intensity by the time, it gives the quantity of electricity. So we want the time here. So the time equals the quantity of electricity over the current intensity. So quantity of electricity 386,000 coulomb over the current intensity, which is 3, okay, 386,000, sorry, fraction 386,000 over 3 gives, it gives here 128,666.67 seconds. So we want it in want this number in hours. So we have to write it here and make division over 60 to render it in minutes, then over another 60 to render it in hours, as the choices here are in hours. So 120,666.67 divided by 60 multiplied by 60 divided also by 60, I mean, so it gives 35.7, which is 0.74, which is the first choice A. Okay, here another example. What is the quantity of electricity required to evolve 355 grams of chlorine gas through electrolysis of sodium chloride? And given that the atomic mass of chlorine is 35.5, we know that the chlorine is monovalent. It is negatively charged with one only negative charge. So the atomic mass equals the equivalent mass. This means that here, this means that 96,500 coulomb, which equals 1 Faraday, is related to the equivalent mass of chlorine, which is 35.5 grams. So in this case, what is the question? He wants the quantity of electricity which is required to precipitate 10 times of this amount. 355 is 10 times 35.5. So it is the same amount of electricity multiplied by 10 by logic. If we do not understand me, okay, render it like this, omit it. Okay, 96,500 coulomb, which is 1 Faraday, will precipitate or will liberate a quantity of chlorine equals 35.5, which is the equivalent mass of chlorine. So how much electricity here in column will be required to liberate 355 grams? Let it calculate it. Let us calculate it. Okay, here cross multiplication. So 96,500 multiplied by 355 divided by 35.5. Let's make it by calculator. Fraction 96,500 times 355 over 35.5 equals, it is 10 times 96,500, it is 965,000, or it is 96,000 500 multiplied by 10. So which of the choices will be 10 times 96,500? It is the choice B, and revise it, it will be very correct. It is B, which is 9.65 multiplied by 10 power 5. So if you want to move the point from here 1 to 0, 0, 0, 3 zeros, okay, it will give the same result, 965,000 or 96,500 multiplied by 10. Another example, how many faradays are required to deposit the atomic mass of magnesium? So the atomic mass of magnesium is 1 mole magnesium reduced at the cathode. 1 mole of it takes 2 electrons to give magnesium 0 solid. So it requires 2 moles of electrons. It requires 2 faradays. So the correct one is 2 faradays. Okay. What is another example? What is the number of the equivalent masses of copper which can be deposited at the cathode of the electrolytic cell of copper 2 sulfate solution after passing a quantity of electricity equals 2.5 Faraday? So he asks about the number of equivalent masses. So here we have a relation. One equivalent mass of any substance like copper require a quantity of electricity equals 1 Faraday. So how many number of equivalent masses is required when we apply 2.5 Faraday? Cross multiplication. Okay, so the number of equivalent masses X equals 2.5 multiplied by 1 over 1. It is 2.5 Faraday. Now the equivalent, it is 2.5 equivalent mass. One equivalent mass requires 1 Faraday. So how many of the equivalent number of equivalent mass will require will be deposited when we use the quantity of electricity equals 2.5 Faraday? Cross multiplication, we found that the equivalent mass of copper when we use 2.5 Faraday as the quantity of electricity will be 2.5 equivalent mass of copper. Another example, on passing an electric current whose intensity is 9.65 ampere, so the intensity here I is 9.65 ampere in 10 minutes, so time here 10 minutes. In an electrolyte, 3 grams liberated mass, 3 grams related to this quantity of electricity, which is 9.65 ampere in 10 minutes. Okay, a monovalent metal was deposited. This is the actual mass of the monovalent metal. So what is the equivalent or the atomic mass? Okay, no problem. The quantity of electricity can be calculated from this relation. It equals the current intensity in ampere multiplied by time, but in second. So the current intensity equals 9.65 times 10 minutes and render it in seconds, so we have to multiply it by 60. So here make calculations. So 9.65 times 10 times 60 equals 5,790 coulomb. Okay, this is the quantity of electricity which deposit this 3 grams. Okay, we'll make a relation. So quantity of electricity which is required to deposit or deposited this amount of grams equals 5,790 coulomb. So how many grams will be precipitated when we use 96,500, which equals 1 Faraday? 1 Faraday. Okay, so by cross multiplication we found that 3 grams deposited or liberated related to 5,790 coulomb. Now X, which is the equivalent mass of this monovalent metal, will required or will be deposited when we use 96,500. Okay, let's make cross multiplication. X equals 3 times 96,500 coulomb over 5,790 gives, okay, let's calculate it together. Fraction 3 times 96,500, okay, over 5,790 equals 50. It equals 50 grams. So what is 50 grams? It is the amount that is precipitated when we use 1 Faraday or 96,500. It is the equivalent mass of any substance. So this is monovalent. So the atomic mass which is required here in the example equals, the atomic mass equals equivalent mass multiplied by the charge. We have here the charge is 1, so the atomic mass is equal the atomic mass equals the equivalent mass of this element. So the equivalent mass of this element is 50 grams. This is C. Another example. Okay, what is the volume of oxygen which can be produced from the acidified water by using a quantity of electricity equals 96,500. Okay, let's have a relation. He wants the quantity of gas which is produced by 96,500 coulomb. This equals 1 Faraday. This Faraday, how much of gas will be precipitated? So let's speak here. Oxygen 2 will be produced by 2 oxides. So 2 oxides have 4 electrons. It is not important that we oxidize oxygen or reduce oxygen. We want to know the amount of the electrons used in moles. So 1 mole of gas of oxygen will require 4 electrons. 4 electrons or 4 moles of electrons. This 1 mole, let's write it here clearly, 1 mole of this oxygen requires 4 moles of electrons. Okay, 1 mole of oxygen, it is 22.4 requires liter in STP, and it requires 4 mole of electrons, so it requires 4 faradays. 4 times 96,500 coulomb. So how many volume in liter will be produced when we use only 96,500 coulomb? Okay, X here equals cross multiplication 22.4 times 96,500 over 4 times 96,500 equals, let's do it, fraction 22.4 times 96,500 over 4 times 96,500 equals 5.6 liter. 5.6 liter. So the correct answer is B, 5.6 liter. Now the last example, according to the equation, 2 molecules of water, liquid, hydrolyzed or decomposed by electric current by 2 hydrogen molecules gas and 1 mole of oxygen gas. So what is the volume of hydrogen gas at STP produced from the electrolysis of the acidified water when an electric current whose strength is 4 ampere is passed for 30 minutes? Now we have the current intensity, it is 4 ampere, and the time equals 30 minutes. Okay, now we can calculate the quantity of electricity used here. It equals the current intensity multiplied by time, it equals 4 ampere multiplied by 30 minutes multiplied by 60 to render it in seconds. So let's calculate it together. 4 times 30 times 60 equals 7,200. 7,200. This is the quantity of electricity in coulomb. Okay, so what do you want? Okay, what is the volume of hydrogen gas? Here, the 1 mole of hydrogen, okay, 2 hydrogen ions requires 2 electrons to be reduced to hydrogen 1 mole of gas. This mole of gas at STP gives 22 or occupied 22.4 liter. So this 1 mole of gas which occupies 22.4 liter will require 2 moles of electron to be reduced. So it uses or reacts with 2 moles of electrons, reduced or oxidized, no problem. We want the number of moles of electrons. So this requires 2 moles of electrons, it requires 2 Faraday. So 22.4 liter of hydrogen to be produced, it requires 2 times 96,500 coulomb. So how much will be produced of the gas in liter when we use this quantity of electricity? 7,200 coulomb. How much of liter? So cross multiplication X equals 22.4 liter times 7,200 over 2 times 96,500. Let's make it together. Fraction 22.4 times 7,200 over 2 times 96,500 equals 0.835 liters. And for this session is completed right now. See you another time. Thank you.